So what is graph? Graph is a set of vertices and edges. So one is connected to one only. So 1 to 1. That means it is self-loop. Symmetric means closed loop between two vertices, and antisymmetric means no closed loop between two vertices. So here you need to check whether it is reflexive or not. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about relations and properties of relations. So today, I will discuss the following topics called relations as directed graph and relation as matrices. Very important concept. You can expect any one question on these two topics. So let's get started now. Relation as directed graph. So already I have discussed about relations and properties of relations, right? So today I will discuss relation as directed graph. So what do you mean by graph? A graph is a set of vertices and edges. So what is graph? Graph is a set of vertices and edges. So here I have three elements called A, B, C. So graph is a set of vertices and edges is called as graph. And each element of this set is represented by a point. Each element of this set, here I have three sets A, B, C. Each element of this set is represented by a point. So this is called as graph. Graph is a set of vertices and edges is called as graph. So relation as directed graph. So what is this relation as directed graph? A directed graph consists of nodes or vertices. So graph means is a set of vertices and edges. So nodes is called as vertices. A directed graph consists of vertices connected by directed edges, or arc. Connected by directed edges, or we can call it as it is arcs. Let R is a relation from set A to B defined as AB belongs to R. Then in directed graph it is represented as edge and arrow from A to B. So here I have two sets called set A and set B. A is equal to AB and set B is equal to B and C. In relation R, I have R is equal to A comma B. So I have two sets, set A and set B. A is equal to A comma B, set B is equal to B comma C. Relation is equal to A comma B. So how to draw a directed graph to this relation? I have two sets, set A and set B. A to B in the sense, so this is A to B relation. So A to B, here I have to mention the points between these two elements A and B. So this is directed graph. So directed graph consists of set of vertices connected by directed edges, or you can use this arcs also. So example, representation of relations using graph. So here, suppose there is a relation 1, 1, 1, 2, 3, 2 on set 1, 2, 3. S is equal to 1, 2, 3. It can be represented by R is equal to 1, 1, 1, 2, 3, 2. So here we have relation R and the sets called as S. In set S, I have three elements called 1, 2 and 3. In set S, I have three elements 1, 2 and 3. So what is the relation? R is equal to 1, 1, 1 to 1, 1 to 2, 3 to 2. So using this relation, we can draw a directed graph. So here I have three set elements called 1, 2, 3. So 1 to 1, 1 to 2 and 3 to 2. So 1 to 1 in the sense it is a self loop. So 1 is connected to 1 only. So 1 to 1. That means it is self loop. You have to mention the direction. So from here have connected to 1. You have to mention the direction using arrow marks. So this is self loop. And 1 to 2. So 1 is connected to 2. 1 is connected to set element 2. So have to mention the direction. So from 1 have connected to 2. So this is directed graph. And 3 to 2. So from 3 to you can connect to 2. 3 to 2. You have to mention the direction. So this is your digraph or directed graph. Digraph is also known as directed graph. So this is your directed graph. You have to mention the arrow mark from one point to another point. So next one, already I have discussed so many properties on relations, right? In relations, we have different properties called as reflexive, transitive, symmetric, etc. So first we'll understand how this graph is related to the properties. So first one we have reflexive property. So what is this reflexive property? Reflexive property in the sense A comma A belongs to R and B comma B is also belongs to R, C comma C, D comma D, etc. So if the relation holds A comma A belongs to R, we can call it as it is reflexive relation. So here we have set element. So A is equal to 1, 2, 3. We have 3 sets elements 1, 2 and 3. First write the set elements of A and we have relation called 1, 1, 2, 2, 3, 3, 1, 2 and 1, 3. We have 3 set elements 1, 2 and 3. So 1 to 1. 1 to 1 means it is self loop. So self loop in the sense first write the self loop and mention the direction, and 2 to 2. Again it is self loop to 2 to 2. So mention the direction and again 3 to 3. So mention the direction. Again it is self loop. So for every point, for every element, we have self loop. So for every element, we got self loop in the sense that means 1, 1 belongs to R, 2, 2 belongs to R, 3, 3 belongs to R. So it is reflexive property. So it holds the reflexive property. So there is a self loop. If the relation holds a self loop means it is called as reflexive property. So self loop on every vertex. And again we have 1 to 2, 1 to 2 and 1 to 3. So this is your directed graph to this relation R. So for every element we got a self loop, then we can call it as it is a reflexive relation. So self loop on every vertex is called as reflexive. Self loop on every vertex. So this is called as vertex and this is edges. If the relation holds self loop on every vertex, then we can call it as it is a reflexive property. It holds the reflexive property. And the next one we have irreflexive property. If there is no self loop, then we can call it as it is irreflexive property. So here again we have 3 set elements called 1, 2, 3, 1, 2, 1 to 2 and 2 to 3 and 1 to 3 and again 3 to 2. Is there any self loop? No self loop. Then we can call it as it is irreflexive. No self loop on every vertex. No self loop. This is called as irreflexive property. And the next one is symmetric property. What is the symmetric property? AB belongs to R and BA belongs to R. So here we have 3 set elements called 1, 2 and 3. So in relation, we have 1, 1, 1, 2, 2, 1. So 1, 1 in the sense it is self loop. 1 to 1 is self loop and 1 to 2. 1 to 2 and again 2 to 1. 2 to 1 and 2 to 3. 2 to 3 and again 3 to 2 and 2 to 2. Again self loop. So here we have 2 self loop. There is no self loop for 3 and we have closed loop on every vertex. In symmetric property, we will get closed loop on 2 vertex. For vertex 1, we have closed loop and for vertex 2 and 3, we have closed loop. So in symmetric property, if you get a closed loop on 2 vertex, that is called as symmetric property. So closed loop between 2 vertex. Closed loop between 2 vertex means it is a symmetric property. It holds symmetric property, that means 1 to 2, 2 to 1, 2 to 3, 3 to 2. This is called as symmetric property. And the next one we have antisymmetric property. So what is this antisymmetric property? Symmetric means closed loop between 2 vertex and antisymmetric means no closed loop between 2 vertex. So again we have 3 set elements 1, 2, 3. So 1 to 1 means it is self loop. Again 2 to 2 self loop, 2 to 3 and 1 to 3. So here there is no closed loop between 2 vertex. Then we can call it as it is antisymmetric. No closed loop between 2 vertex. So opposite of symmetric is antisymmetric. And the next property is asymmetric. Asymmetric in the sense no closed loop and no self loop. Then we can call it as it is asymmetric. So no closed loop and no self loop. We have 3 elements 1, 2, 3. 1 to 2, 2 to 3 and 1 to 3. There is no closed loop and no self loop. No closed and no self loop. Then we can call it as it is asymmetric property. This is your directed graph for asymmetric property. There is no closed loop and no self loop. Then we can call it as it is asymmetric property. And next property is transitive property. So what is this transitive property? AB belongs to R, BC belongs to R, then AC belongs to R. So this is called as transitive property. So how to draw a directed graph? So here we have 3 set elements 1, 2, 3. So relation is 1 to 1. This is self loop and 1 to 2, 2 to 3 and 1 to 3. So what is transitive? Transitive means A to B, B to C, then A to C. So 1, 2, 3. 1 to 2, 1 to 2 is there. 2 to 3, 2 to 3 is there. 1 to 2, 2 to 3, then 1 to 3. 1 to 3 also is there. So A to B, then B to C, then A to C. So 1 to 2, 2 to 3, then 1 to 3. So this is called as transitive property. So A to B, B to C, then A to C. So we have in relation we have 1 to 2, 2 to 3 and 1 to 3. So this is called as transitive property. The next problem is the directed graph of relation. We have relation R AA, AB, BB, BC, CC, CB and CA. Here So here we have to draw a directed graph and we have to find whether it is reflexive, transitive or symmetric. How to draw a directed graph for a given relation R? So here we have three set elements called A, B and C. So A to A means it is a self loop, and A to B. And B to B means it is a self loop, and B to C to C, self loop, and C to B, and C to A. So this is your directed graph for a given relation. Here you need to check whether it is reflexive or not. So we have A, B, B, C, C. So it is reflexive. We have self loop for three set elements A, B, B, C, C. So it is reflexive property. And we have AB, BA is not there, and we have BC, CB is there. So it is neither symmetric nor asymmetric. And we have AB, BC and CA. And R is not transitive as there is an edge from A to B and B to C, but no edge from A to C. We have A to B and B to C. There is no edge from A to C. So it is not a transitive property. So it is a reflexive and it is not a transitive property. So this is your directed graph. In the next question, given A is equal to 1, 2, 3, 4, consider the following relation in A. Is AR reflexive? Here you have to find it is a reflexive or not. We have four different elements, 1, 2, 3 and 4. 1 to 1, it is self loop, and 2 to 2, self loop, 3 to 2 and 4 to 2 and 4 to 4, it is self loop. So this is your directed graph for a given relation. 1 to 1 is self loop, 2 to 2 is self loop and 2 to 3. And here I missed out this 2 to 3. 2 to 3 and 3 to 2 and 4 to 2 and 4 to 2 and 4 to 4. So this is your directed graph. So here you need to check whether it is reflexive or not. So here we have three self loop for 1, 2, 4. 1, 1 is there, 2, 2 is there, but 3, 3 is not there, 4, 4 is there. So it is not a reflexive property. Not reflexive because 3, 3 is not belongs to R. So it is not a reflexive. And the next problem, given A is equal to 2, 4, 6 and B is 4, 6, 8. Here we have two sets, set A and set B. But in set A we have 3 elements and set B also we have 3 elements. 2, 4, 6 and 4, 6, 8. How will you draw a graph using these two set elements? So first you have to find A union B. So what is A union B? So A union B is 2, 4, 6, 8. A union B is 2, 4, 6, 8. If you get any repeated value, you need to write only once. So 2, 4, 6, 8. So this is your given set elements. For this, you need to draw a directed graph using this relation. So 2 to 4. 2 to 4 and 2 to 6 and 2 to 8 and 4 to 4 self loop and 6 to 6 self loop and 6 to 8. 6 to 8. So this is your directed graph for a given relation R. So here we have 4 to 4 and 6 to 6. But there is no 2 to 2 and 8 to 8. So it is not a reflexive. And 2 to 4 is there, 4 to 2 is not there, 2 to 6 is there, 6 to 2 is not there. So it is not a symmetric also. So this is your directed graph for a given relation. So R is a subset of A cross B. So in directed graph, you have to mention the direction between the 2 points. Then it is called as directed graph. And the next concept is relation as matrices. So I hope you have studied this matrices concept in 2nd PUC and school days also, right? So this is regarding matrices. So relation as matrices. A relation R is defined as from set A to set B. Then the matrix representation of relation is MR. So matrix representation, that means M number of rows and number of columns, where Mij is equal to 1 if AB belongs to R, 0 if AB belongs to R. So here we have to use 1 or 0 for representing a matrix. So MR stands for matrix representation and Ij stands for number of rows and number of columns. So how to represent a matrix using relation? A relation R is reflexive if the matrix diagonal elements are 1. So reflexive in the sense AA belongs to R, BB belongs to R, CC and DD belongs to R. So here we have matrix representation for A, B, C, D, A, B, C, D. So how will you find the matrix for reflexive property? AA belongs to R and BB belongs to R, CC belongs to R and DD belongs to R. So it is called as reflexive property. So R is reflexive if the matrix diagonal elements are 1. So diagonal elements are 1. Then we can call it as it is reflexive property. So in reflexive matrix representation, all the diagonal values should be 1 because AA is equal to, because AA belongs to R, BB belongs to R, CC belongs to R and DD belongs to R. All the diagonal elements are 1 in reflexive property. And R is irreflexive if the matrix diagonal elements are 0. So if it is reflexive means all the diagonal elements are 1. If it is irreflexive means all the diagonal elements are 0. If it is irreflexive means all the diagonal elements are 0. Reflexive means all the diagonal elements are 1. If the transpose of relation matrix is equal to its original relation matrix. So symmetric in the sense AB belongs to R and BA belongs to R. So we will get 1, 1, 1 and all other elements are 0. So this is your matrix representation. So let us understand with an example, very important question. So let A is equal to 1, 2, 3, 4, B is equal to B1 and B2. So A means it is a number of rows and B is number of columns. So how to represent a matrix using this relation? So MR matrix representation is equal to 1, 2, 3, 4 and in B we have two elements called B1 and B2. So here we have a relation 1B1. So from 1B1 you can put 1 and 2B1 is 1 and 2B2 is also 1 and 3B2 is 1 and 4B1 is 1 and the remainings are 0, 0, 0. So this is your matrix representation using number of rows and columns. So using two sets we can represent a matrix like this. So number of rows and number of columns. So this is your matrix representation. And the next problem is, given a relation matrix MR, the relational set from A to B can be written. Here we have a matrix representation. Using this matrix representation, we have to find the sets and we have to find the relation. So here we have two sets. Set A is equal to 1, 2, 3 and set B is equal to B1, B2, B1, B2, B3 and B4. We have 3 set elements in A and 4 set elements in set B. So here we have to find relation R using this matrix representation. So from 1 to B1 we have 1. So 1 comma B1. In place of 1 B1 we have 1 and 1 B3, 1 B3 and 1 B4 and 2 B2, 2 B2 and 2 B3 and 3 B2, 3 B3 and 3 B4. So this is your relation for a given matrix representation. We have two sets. Set A contains 1, 2, 3 and set B contains B1, B2, B3, B4. So using this matrix representation, we can find the relation. So this is your relation of a given matrix. And the next problem is, A is equal to 1, 2, 3, 4. R be a relation on A defined by, we have relation R. Determine the matrix relation and draw a digraph of R. So here we have to find the matrix representation and also we have to find the digraph or directed graph. We have set A and set B. Set A contains 1, 2, 3, 4. So here we have only one set elements, that is 1, 2, 3, 4 only. So what is the relation? 1 to 1. In place of 1 to 1, I will put 1. And 1 to 2, 1 to 3, 1 to 4. And 2 to 2, 2 to 4, 3 to 3 and 4 to 4. The remainings are 0, 0, 0, 0 and 0, 0, 0. So this is your matrix representation for a given relation and also we can we have to draw a digraph. So here we have 4 set elements 1, 2, 3 and 4. 1 to 1. So it is a self loop and 1 to 2 and 1 to 3 and 1 to 4. And again 2 to 2 is self loop, 2 to 4 and 3 to 3 is self loop and 4 to 4 is self loop. So this is your directed graph or digraph and this is your matrix representation. So very important question. Easily you can score on this topic. And the next question is, let A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4. We have a given relation. So here determine the matrix relation and find the complement of R. So here first we have to find matrix representation. We have two sets, set A and set B. So set B contains 1, 2, 3, 4. Relation R 1, 1, 1, 3, 2, 4, 3, 1, 3, 2 and 3, 3 and remainings are 0, 0, 0, 0, 0. So this is your matrix representation. So here you have to find the complement of R. Complement of R means, so first find out, so here we have to find the complement of R. So here this is matrix representation. So first find out the complement of this matrix representation, that is M dash R. So what is the complement of this? Wherever you have 0, that will be 1, 1, 0, 1. 0 means it is 1, 1, 1 and 0. 1 means 0, 0 means 1. 0, 1. So now you can find R complement. Here you have to find the complement of R. So in place of 1, 2, we have 1. So 1, 2 and 1, 4 and 2, 1, 2, 2, 2, 3 and 3, 1. So this is your R complement. So here we have relation R. For this you have to find the matrix representation. After that easily you can find the complement of this matrix representation. Then you will get the complement of this relation R. So you can cross verify this. So here we have 1, 1, 1, 3, 2, 4, 3, 1, 3, 2 and 3, 3. But here we have 1, 2, 1, 4, 2, 1, 2, 2, 2, 3 and 3, 1. This is a complement of this relation R. So this is about your relation as matrix representation. In my next session, I will come with a new concept called functions. Thank you.